As researchers with combined expertise in teaching computer programming and curriculum development, it's clear that this curriculum is about computer programming despite the fact that the state only uses the term coding. Coding is the most basic aspect of learning programming. Many governments have also made this change, such as Estonia as early as 2012, the UK in 2014, and South Korea in 2017. But what are the arguments put forward to motivate the integration of computer science and more specifically computer programming into the school curriculum of students? Research highlights three main arguments on this subject that will be discussed. The first one is meeting the growing needs of the job market. The evolution of global job market represents one of the motivation at the heart of the integration of programming in school curriculum. This motivation, widely promoted by policymakers, is essentially linked to the need to train more people with programming skills. Indeed, technological knowledge, particularly in the high-tech sector, has been driving economic growth in North America and elsewhere in the world for over 20 years. A growing number of jobs require a deep understanding of technology. This number of jobs is actually expected to increase in the coming years, considering the data science, artificial intelligence, and decentralization technologies such as blockchain on which cryptocurrencies are based, considering that there are many stereotypes associated with it. Some studies also argue that exposing students to computer programming early in the school curriculum could have a positive impact on the identity they develop with respect to this field. Second one is promoting social equity. According to several authors, greater exposure to computer science by teaching young people how to program could also help promote greater social equity in terms of representation and access to technological profession. On the one hand, computer science skills can indeed provide access to well-paying jobs, which could help provide greater financial stability for marginalized groups who have not had the opportunity to accumulate wealth in recent generations. On the other hand, the increased participation of people from underrepresented groups in computing, women, indigenous people, black people, could also promote diversity in the field and ultimately result in an increase in the total number of workforce. In addition, there is a related argument that greater diversity within the workforce will lead to better product accessible to a greater portion of consumers in the marketplace. Too much homogeneity among workers leads to the design of products and services that cater to a relatively narrow spectrum of individuals and problems, which may reinforce some inequalities. Researchers advancing this equity argument argue that if early and intentional steps are not taken to foster greater diversity, this could result in a digital gap or an opportunity difference between dominant and marginalized groups, much more pronounced in the coming years. All youth learning to program could, in this sense, represent a measure to decrease this gap and promote greater social equity, which is in line with United Nations goal for about inclusivity and equality in education. The third is developing learners' cognitive skills. Finally, the most commonly mentioned argument concerns the role of programming would play in developing computational thinking in learners. Defined and popularized in 2006, the concept of computational thinking refers to the skill of problem solving, system design, and understanding human behavior based on the fundamental concept of computer science. Several authors argue that the development of such computational thinking would be beneficial for the learners as it would allow them to develop high-level reasoning skill that can be transferred to other learning such as problem solving, creativity, and abstraction. For these reasons, computational thinking is often embedded within new programming curriculum, such as in England's curriculum, where it is stated that high-quality computer science education equips students to use computational thinking and creativity to understand and change the world. The introduction of programming into the school curriculum could therefore have a benefit for all students, even those who are not destined for a technological career, as they could benefit from computational thinking in their daily lives in a more cross-curricular way. It is important to note, however, that these beneficial effects for the learner, although widely discussed and increasingly documented, still need to be shown through more research involving comparative and longitudinal aspects. In sum, it appears that the decision maker have seen the potential of triple benefit of youth learning computer coding for the future. However, the major challenge is the lack of sufficiently qualified teachers to adequately introduce this complex discipline to students. Adequate staff training will be a key requirement for successful integration of this computer programming integration. One potential solution could be to integrate programming into the initial university training of future teachers.